Hola, Mónica, buen día. How are you?
Hi, teacher. Fine, thank you. You?
Doing pretty well also. Thank you.
Hello, teacher.
Hi, Mauricio. How are you?
Everything fine, thanks.
I'm glad to hear that. Did you saw your grade?
Yes, thank you.
No, don't thank me. Thank yourself. Thank God you sent an advance and I was able to give you some feedback so you could change numbers, no?
Yes, I got a little bit confused because I think the exercise we made in class, I think it was already finished, so that's why I sent it incomplete, but then I realized it was incomplete, so I changed it.
Exactly. So always read the rubric. That would be an excellent thing to do always, okay?
Yes, yes.
Hi, teacher. Good afternoon.
Hi, how are you?
Fine, thanking you.
Doing pretty well also, thank you.
I'm glad.
Inés. Erika Peralta. Okay, let's give some time to the rest of the group to get connected. Meanwhile, we can work a little bit on today. You got homework, and my expectation is that you will finish the homework before we leave. We'll finish. Okay, so I'm going to bright space, Blackboard, no, not anymore Blackboard, it's bright space. Here in contenido for week 14, we got activity 09, waiting line, okay? Let me move the image over here and let's read it. Activity 9, the Burger Dom waiting line case. For the Burger Dom single server queue, remember we saw the case last class. Now they're asking to please suppose that the arrival rate increases to 1. It was 0.75 before and now it increases to 1 customers per minute, and the service rate increases. Sorry.
Bless you.
Thank you very much. Thank you. And the rate increases to 1.25 customers per minute. So you're going to be doing your homework on Excel file, okay? Be sure to read the rubric to meet all the requirements, okay? So I'm going to check exactly what does it say so there's no doubts. Here we got it. Okay, now this is perfect. Okay, solve the following burger dump single server waiting line case, okay? So the same, I just read before. Arrival rate increased to 1 customer per minute, while the service rate increased to 1.25 customers per minute, okay? They're asking you to calculate the operating characteristics, the following one for the new system. PO, LQ, L, WQ, W, and PW. We're gonna see right now how to calculate them, okay? And then, does the system provides a better or a poorer service? Make a comparative table. And after that, discuss any difference in the reason for this difference, okay? So we're gonna, at the end of this class, you're gonna have answers for all of this, okay? The activity is to be done on Excel worksheet, okay? Once finished, you got to submit the Excel worksheet in Brightspace, and you're not gonna be using any Word file here, okay? And please, before submitting, review the evaluation rubric and make sure to include the required information, okay? So let me close this. Okay. And let me go back to the call roll because I heard the bell of someone of you guys coming in. It's Ernesto Gonzalez with us? I don't think so, right? Okay. Sara?
Yes, I'm here.
Okay. Carla?
I am here, teacher, Ernesto González.
Okay, I'm glad to hear you, Ernesto. Carla, are you there? Not yet. Luis Peña? Luisa Rendon?
I'm here, teacher. I just gotta open my front door.
Yes, teacher. Luisa.
Okay, and Luis, right? Melissa, is she with us?
Here.
Okay. Miguel Rodriguez? Not yet. Rafael Rosas? Not yet. Mauricio Serra? Is
Here,
he with
teacher.
us?
Yes,
Okay.
here. Thank you.
Manuel Suarez? Pablo Vasquez? Okay. Let's start with the topic so that you can work on your homework. So today we're gonna work section 15.2 that says single server waiting line model with Poisson arrivals and exponential service times, okay? When we say single server, we refer mainly to this. I'm going back to the presentation we have last class, refers to this, okay? This is a single waiting line, okay? It's one, okay? So it says single server waiting line model, okay? So it's one line where we got here the lambda that will be my serving rate, and I got here my order filling. I got here a dispatcher, okay? And here I got my mu. Remember, it was my service rate, okay? And if we remember, here we say that for an arrival rate of 45 times per hour, what we did is we calculated per minute. So it would go to 0.75 times per minute. Okay, that was the numbers we were using before. Okay, and also we say that the dispatcher was able to do 60 orders per hour, that would be 1 order per minute, okay? Now, having those numbers in the memory, let's go back to our second PowerPoint presentation, okay? So we're gonna be using some operating characteristic of this Burger Dom fast food restaurant, and they can be used on any waiting line model, okay? We start mainly using lambda and mu, and remember, we're considering that the distribution, it's exactly a Poisson distribution for the arrivals, and regarding the services, we have an exponential distribution. Those are, we're assuming those two, okay? Now, we're gonna be calculating 7 different topics. The first one, the probability that no units are in the systems. When we say units, we refer to customers, okay? Presentation, it's already in bright space if you want to bring it down, okay? So there, the probability that no customers are in the system is gonna be given by PO. The average number of customers in the waiting line is going to be LQ. Then the average number of customers in the system. When they say system, let me go back over here. Okay, so for example, LQ, it's the average number of customers. It refers to this one, LQ, okay? While L is the average number of units of customers in the whole system, refers to, this is the whole system, it's L. Okay, so there's a difference, okay? Then for average time, that would be in minutes, customer spends in the waiting line, that will be WQ. Average time a unit spends in the system, that would be W. Now, if you see, this is quite interesting. Every time it's referred to the waiting line, they use a Q over here. And when we say the whole unit is a part of the line plus an extra, okay? Part of the line plus an extra, okay? Now, probability that an arriving customer must wait for the service, that will be PW. Okay, and probability of n units in the system, it's going to be Pn. I know right now there's no meaning for you. Give me just 1 second and we're going to start understanding these numbers, okay? Now, it's quite interesting seeing that the arrival rate and the service rate are important components for all these formulas, okay? So we got to be sure that we got these 2 numbers pretty well, okay? And there's one condition. Equations 15.4 to 15.10, that means all of this. We can only apply them when m is greater than lambda, okay? If this is not happening, okay, what it's gonna happen is that the waiting line will continue to grow without limit because the service facility doesn't have enough capacity to handle the arriving units, okay? So here we got a lambda of 0.75 and our mu is equal to 1. This one must be higher than lambda because that means that this one has enough capacity to attend the whole line. But when lambda is greater, we're in problems because the only thing that is going to happen is that the line is going to be increasing, okay? We don't have enough capacity in the service area, okay? Now, let's apply here the formulas and start to understand them, okay? So for lambda of 0.75 customers per minute, that would be my arrival rate, and the service rate of 1 customer per minute, we're going to have the next figures. My probability that no customers are in the systems is going to be of 25%. okay? The average number of customers in the waiting line with these numbers is of 2.25 customers. That means that we're going to expect to have 2.25 customers here per minute, okay? The average number of customers in the whole system is 3 customers. The average time a customer spends in the waiting line is of 3 minutes, okay? And the average time a customer spends in the whole system, it's of 4 minutes. So we got a nice idea of how this waiting line is operating, okay? The probability that an arriving customer must wait for service, it's of 75%, okay? And the probability of n customers in the system reduces, okay? First, what is the probability of having non-customers? It's of 25%. Probability of having 1 customers, 19%, 2 customers, 14, 3 customers, that would be 11, and so on, all the way to 7, that would be 3.3%, okay? Now, these figures will help us to understand where are we standing. The managers use these figures to understand where are they standing and what can they do for. For example, customers wait an average of 3 minutes before they start placing an order. It's this one, no? This one. Okay. The average number of customers waiting in the line, we refer to this one. So they're the same, but just written in a different format, on a different way. 75% of the arriving customers must wait to be served. Where can we find that one? Here. So here we got 2 options in order to make a better service. What are the 2 options or the 2 alternatives? The first alternative is increase the service rate. That means we can do something here, okay? By making a creative design change or by using new technology. My second alternative would be to add 1 more server so that more customers can be served simultaneously. That means that instead of having 1 line and 1 cache taking the order and then filling the order, I will have 2, not cashers, 2 dispatchers, okay? So they will be going to different positions, okay? That will be my second option. Now, we're gonna study today the first alternative, and on Tuesday, we'll go over the second alternative. Alternative 1, okay? So what they're proposing here, an order preparer is employed to assist the order taker at the cash register. That means that behind this server, okay, here we got the line, and then we got here, and they take us the order. We got here 1 person taking the order and filling. Now we're gonna have the order taker. This is gonna be the order taker. And behind him, we're gonna have an order preparer or filling. Well, the filling, order filling. I prefer saying order filling. Okay, I think this translation. I don't like this one, although it's from the book in English. Okay, so the idea is you come in, okay, and the order taker says, okay, can I take your order? Sure. Okay, I want a burger, I want some French fries, and I want a soda. So this guy takes the order, repeats the order and say, do you want something else? No. Before cashing, the customer has the order to the order filling, and meanwhile, this one cash the customer, this one moves quickly and we'll put the order here so that then after cashing you just take your order and leave. Okay, so we're putting a second person behind this order taker, the order filler. Okay, let me close the door. When one dog barks, the rest of the dogs start barking too. It's like they have their own language, no? Okay, so what happened after this? So it says the customer initiates the service process by placing the order with the order taker, okay? When the order is placed, the order taker announces it through an intercom system and the order filler begins to prepare it. Then the order is complete, the order taker gets paid while the order preparer continues his work. With this design, watch. It's estimated that the service rate can be increased. Now, instead of attending 16 customers, we were able to move to 75 customers per hour. That means that mu, that was before 1 customer per minute, increased to 1.25, okay? And my lambda stays the same in both cases, okay? 0.75 and 0.75. So what I did is a change in service. And if we compare figures, it's quite interesting seeing how we got a better situation, okay? The probability that no customers are in the system here is of 25, here increased to 40, and that's nice. The average number of customers in the waiting line dropped from 225 all the way to 0.9. The average number of customers in the system dropped also from 3 to 1.5. Average time a customer spends in the waiting line, now instead of spending 3 minutes, they're going to spend only 1.2 minutes. The average time a customer spends in the whole system, there were 4 minutes, now it's half, 2 minutes. The probability that an arriving customer must wait for service dropped from 75 to 60, and the probability of 7 customers in the system dropped from 3.3 to 2.8. So now our numbers are in better shape, okay? We got a second alternative, definitely, okay?
Teacher, I don't understand the first one. Probability that no customers are in the system. That is
Yes.
bad, right? You want
That
customers
we
in
don't
the
have
system.
customers. Yes. ¿Qué probabilidad hay de que no haya clientes en el sistema? De que te quedes sin clientes. Porque
Yeah.
los vas atendiendo. Los vas atendiendo con cierta rapidez y entonces mejora tu probabilidad. Do you agree?
Ya, entendí. Va, gracias.
Okay. Okay. Now, we can always add one or more servers, okay, so that orders for multiplied customers can be filled simultaneously, okay? But that would be alternative 2, and that should be seen next Tuesday, okay? So please open an Excel sheet, and please, we're gonna start doing the homework. Instead of putting here these numbers, put them here, 0.75, and here's gonna be 1, okay? Remember, this is mu, and this is lambda, okay? So if you want to go over your Excel, open it. It's 17:53. I'm gonna be back in 10 minutes. So more or less about 18:05, okay? I leave you with this page open. If you want to see the formulas, you can download from Brightspace my PowerPoint presentation, okay?
Okay.
So we start doing this.
What did you say, Mauricio?
Sorry. We have to start doing this exercise, right?
Yes, this is going to be part of your homework.
Okay.
Monica, are you done? Are you finished?
I already finished, teacher.
Okay, Mauricio.
Me too,
good.
teacher.
Okay, Eugenia, Inés, finished. Erika, Diana. So that was easy, wasn't it? Okay, Melissa.
I'm almost done, teacher.
Okay, okay, perfect. Luisa, done. Okay, Georgina. Sara, okay,
Almost.
almost, okay. Arnoldo, where are you, Arnoldo? Arnoldo. Arnoldo, where are you, Arnoldo? Arnoldo. Uno menos. Luis Peña, are you there? Luis Peña, are you there? Okay. No están conectados, se van. Be sure not to turn off your camera or I'll put you away. Sorry for that. Okay, so Mauricio Luna, can you show us your screen, please? Let me stop sharing.
Yes, no problem. Let me share it.
Okay, now
You're
that's
watching?
nice. Yes, now you were supposed to put the 0.75 and the 1 in column C, remember? Now, so cut them and move them.
To the column
Control-
C?
Yes. Okay, now that's nice. Now watch. Copy column C, choose the whole column C. Okay, Control C, copy, and paste it in column D.
Okay, ready.
And now you can change the figures. Remember the figures of lambda and mu for the homework?
Yes,
1 and 1.25.
Why did you erase? Don't erase them. Don't erase column C. Leave it like that, okay?
okay.
So in column D, it was 1 from lambda.
Yes,
And what was the other one, Eugenia?
1.25.
1.25. Okay, so if you watch your figures, we got that the probability of no customers in the line reduces from 0.25 to 0.2. So that went down, it's not good. The average number of customers in the waiting line increased. The average number of customers in the system increased from 3 to 4. The average time a customer spends in the waiting line went from 3 to 3.2. It's also went bad.
it's better the first column, no?
Yes, it was the original figures, no?
Yes,
Average time of a customer spent in the system went from stays at 4. And the probability of arriving customers went from 75% to 8%. Now, can you change the format for those that are probability?
which ones?
The 0.25 and the 0.2, the two first, those?
These ones?
PO, yes.
Yes.
Those two, choose that line.
This one?
No, not the column, the line.
This
okay,
one?
change the format to percentage.
Okay. Ready.
Okay, also for the last one, that it's also a probability, no? Okay, and can you please change the rest of the numbers to 2 decimals so that we can compare them? Also the 2 decimals. Okay, and also the 3.2.
Oh, yes. Wait a minute.
Okay,
Ready.
so can you explain us what happened, Mauricio?
Yes, well, it's better have a lowest arrival rate and a low service rate, so we will be more efficient. We will have more efficiency at the waiting line and in all the system and preparing all the food. So what I'm seeing, it's better having low percentage and low arrival rate and service rate
Okay,
to be
okay,
more
those
productive.
you're just talking about numbers. What's exactly the arrival rate?
0.75.
But what's the meaning of the arrival rate?
How the people arrive to the restaurant, to the burger
How
store?
many people arrive? So
How many people arrive?
Okay, so what's the feeling of what happened? Can somebody give me some explanation here? Any idea?
I think that more people is coming in,
Yes.
and the service rate also improved a little bit, but I think that they are, how do you say, they grew proportionally, 0.25 each.
Okay, how can you prove that with numbers, Mauricio? That was a nice point. You're giving the answer for question number 8. But the point here is, how can you prove it?
I would do percentage increase between each.
Okay, thank you, Mauricio Luna. Can now Mauricio Serra share us your screen, please?
Yes,
Nice
yes,
work,
yes.
Mauricio, by the way.
Thank you.
Okay, Serra, can we see your screen now? Ernesto, if I don't see you, I'm going to dump you out of the class.
Here, ready.
Ernesto, are you there? Ernesto, are you there? Yes or no? Gosh, why it's so difficult?
Yes, teacher, sorry.
Mister, if I don't see you, I'll bring you out of the class. Can you please turn on your camera, please?
Yes, yes. I am
Now,
here.
don't turn it off. How many times do I have to ask for that? Next time I see someone turning off the camera, I'll dump you out of the class, okay?
Okay,
Thank you.
you're welcome.
Okay, sorry, Mauricio, for that situation. How
Don't worry,
can you
teacher.
prove us that, Mauricio Serra? Any idea?
Yes, the 0.25 is because each one of these was 0.25 increase.
Okay, wow. Okay, you're close. You're close to the
And
explanation.
I think that in percentage increase each should be the same, no?
Okay, why don't you go where you put the first 0.25 and write a formula that it's going to be plus C7 divided by CB minus 1.
CB divided by CB minus 1?
B7. C7 divided by C7 minus 1. No. Yes. Sorry, you're correct.
Minus 1?
Yes. How much do you get there? No, there's something wrong. You divide it.
Here.
Okay, can you give a percentage format there? Okay, can you copy that formula down? Luisa, any idea of what's happening now? What happened with the arrival rate? Increase how much?
0.33.
33%.
Yes.
Okay, so more people is coming in. Do you agree? That's the first one is 0.75 per minute. The second one, it's 1 person per minute. If we put it on hours, it would be the first one, it's 45 people per hour. And the second one, it's 60. That means it increased from 45 to 60. That's a 33%. Now, Sarah, any idea of what happened with the service rate, the mean? It increased only 25%.
You divide the option 2.
Okay, by
And-
option 1, in order to understand how much it increased. Did they increase at the same rate?
No.
No. That's our problem. Okay, what would happen, Mauricio? Instead of 1.25, you put 1.33.
Okay, now they are growing the same at the same rate.
They are close, no? They are a little bit different because you got
Yes, 0.33.
the first one, probability that no customers are in the system is going to be 25 and 25, while the average customers is 2.25 against 227. That one, it's a little bit worse. Those are number of customers, okay, but it's not that bad. The average customer in the whole systems went from 3 to 303. Average time a customer spends in the line, it's 3 against 2.28. So that one's, it's better. And then average time a customer spends in the whole systems went from 4 to 3. Okay, so now can we go back to our original 1.25? Eugenia, any idea of what's going on? Or Erika, what we're looking at? What's your feeling?
Well, I think that the arrival rate increased and also the service rate, but it's not suficiente.
Exactly, it's not enough.
Not enough.
Okay.
Yes, not enough.
So, I'm gonna talk at the air. Voy a hablar al aire sin tener elementos. But I got the feeling that suddenly we have 33% more than average, and they were able to increase the service rate 25%, but that was not enough. I mean, they work it out, but it wasn't enough to keep the numbers they were having before, okay? So they dropped, the numbers drop a little bit from 25 to 20%, or from 2.25 to 3.2. So that means it looks like suddenly more people came in and they did something in the restaurant, but it was not enough in order to compensate the number of people coming, no? And that you can see it with the 33 against the 25. Do you agree?
Yes.
So that would be answered for question number 8. Yes or no?
That the increase in service rate was lower than the arrival rate, right?
Yes.
That's the problem? Okay.
The arrival rate increased more than the service rate. They didn't increase at the same rate. Another option would be that instead of being the lambda number 1, just increasing 0.75. Go to the 1 in option 2. Okay, and multiply 0.75 times 1 time plus times 1.25.
1.25.
Yes. Carla, did you just connect? Okay, so if you see, we got the same numbers, more or less.
Yes, but in the average time a customer spending the line gets down, no?
Yeah, it's better.
It's better, and the average time in the system is the same.
It's better. I mean, some figures stay the same, and the average time a customer in the waiting line and in the whole system, they are now better. Okay, questions?
Can I
Do
see
you
the
have-
formula again?
Sure, which one?
The one that's over the cursor. No, the one on top. That.
Okay, what we did is we are estamos forzando a que la tasa de llegada, Melissa, también crezca en el mismo porcentaje que la tasa de servicio. Although it's not the final number, okay? Remember that one, it's 1, okay? Go back to the number. We did it just for understanding what's going on. Okay.
Teacher, I have a little question. Can you put
Yes.
the cursor in that one? Yes, because I lost a little
Okay.
bit there.
Okay, the owner of the worksheet is Mauricio Serra, Mauricio Luna.
Ah, okay. Sorry. I think it was yours.
No, no problem.
Don't worry.
Thank you.
Okay, so if you guys want to finish your homework, I'll be glad if you try to load it in the next few minutes. Right now it's 18:23. That means we got 22 more minutes before we finish class. Why don't you try to load it right now on the rest of the class? Okay?
Okay.
Thank you, Mauricio, for sharing your
You're welcome, teacher.
Okay. Monica, can I see your worksheet? Carla, did you just came in?
Hi, teacher. Yes.
Oh,
Here is teacher.
okay. So you're not understanding what we're doing.
No, but I'm going to see the class, the recording
Video.
class.
Yes,
Yes.
I'm gonna try to put it as fast as I can. Okay, that's
Yes,
nice.
teacher. Thank you.
Okay, thank you, Monica. Somebody else wants to share the screen? So
Me,
this
teacher.
was Lisa, okay. I think it's like we're trying to understand the numbers we're using, but it's not really that difficult, okay? We're not going over the formulas because I'm not interested in trying to understand them, but we're more like we're trying to use them, okay? Who's showing right now? Lisa? Okay,
Yes.
that's better. Okay. That 426, can you reduce it only to 2 digits?
What?
You got an error somewhere over
Yeah,
there,
in
no?
this one, but I don't know why.
Okay.
I have the
Uh,
same numbers.
Okay, let me go over, first change the format, put 2 digits number.
This one?
No, below. Vete en donde dice 225, go down over there. Selecciona desde el 225 hasta el punto 8. Más abajo, más
Ya.
abajo.
Ya lo vi. Ay.
Ok, dale formato de 2 decimales. 2 digits number. Okay, that's 4. Okay, now that's better. Okay, so let's go to the 225, 395. Okay, can you copy the formulas from B to C?
Are the same, I think.
They're the same? I don't see the, give me a moment because I'm not watching your formulas. I have here this, okay, you say they're the same. Okay, stay there.
Okay.
14 entre B7 de 8. C14. Why is related to C14? That's like, no, there's something wrong in your formulas. Okay. Ve al 25%. That one is okay. Can you go now down? Okay, that one is nice. Can you go one more down? That's C14. It shouldn't be C14, it should be B14. Enter.
Oh.
Now copy
one
that,
too?
the same formula to the right. Also, that one should be okay. Now that's better. Okay,
Thank you.
you're welcome. Excellent. Somebody else say over there that had the same problem?
Me, but I think now it's okay.
Okay. So continue with your homework. Try to send it before we continue.
Teacher, for question 7, it is the 2 columns, the table that you want to see.
Again, question 7 is, well, question 7 is exactly what you have done right now, the comparative table, no? That's okay.
Okay.
It's that's question 7,
Okay.
comparing them.
Okay, thank you.
Ernesto, he is gone. Yes. Carla, you will find a PowerPoint presentation in Brightspace. There is the activity that they're doing right now, and there's a PowerPoint presentation. If you read the PowerPoint presentation, that will be more than enough for you to understand what you got to do. Okay?
Okay. Yes, I'm going to download now. Thank you.
Miguel never connected, right? He was absent. Rafael Rosas, I never saw him. Francisco Suarez, I caught him also, right? Pablo Vasquez, he didn't connect.
Teacher, if we already sent it, the class is over?
Yes, you may leave.
Ah, okay. Thank you, teacher.
Have a nice weekend.
Same to you. Bye.
Somebody else have finished also?
I'm uploading it in just 1 minute and I'm finished. Ready, teacher, I already sent it. Thank you.
Okay, Mauricio, have a nice weekend. See you.
Same you. Goodbye.
Bye-bye.
Can we do that?
Can you do what?
Just put the
Again?
increase.
What was your question, Melissa?
Wait. And that counts, like you're not going to put me worse. Just put the increase between option 1 and option 2 down below.
Can you show me your screen?
I already
Estoy
finished,
explicando.
teacher. Thank you.
Me too. Thank
Bye,
you, teacher.
Monica. Bye, Eugenia.
Bye.
Okay. Okay. I'm gonna, okay, share. Okay.
Okay, you
Can
got
I
the
just-
numbers.
Yes.
Now you got to explain the difference, no?
It says make a comparative table.
That's
I
your
just-
tip.
I do this. Okay, okay. I thought I had to do something like this increase, but like here.
No, you already have your comparative table. That's it, no?
Oh, so I just have to put the difference between.
Okay, now beware where it says you got two LQs. Where it says average number of customers in the system, it's not LQ, it's L. Abajo. Take off the Q, okay. Te falta explicar el motivo del cambio. And that's
Okay.
it, Melissa.
Okay, okay, yeah. How do I stop sharing? Okay, here.
Okay, there you go.
Teacher, I think I finished. Thank you.
Okay, thank you. Have a nice weekend. Bye.
Bye, teacher. Thank
Bye,
you.
Sarah. Have a nice weekend.
You too.
Thank you, teacher.
Bye-bye.
Bye, teacher. Thank you.
Bye, Hel.
Bye.
Have a nice weekend.
You too. Thank you.
Teacher, when are we going to, no, when is the last day to send you the homework?
Next Tuesday.
Okay. I prefer to see the video of the class because
No problem.
lost. Yes.
No problem, Carla.
Nice.
I will try to submit it as fast as possible.
Okay. Thank you. And I send you a message and explain you why I'm late.
Don't worry. Don't worry. It's okay. Okay?
Okay, thank you.
Have a
teacher.
nice weekend, Carla.
You too.
Teacher,
Yes,
I already sent the activity.
perfect, Ines. Thank you very much.
Bye, teacher. Have a good weekend.
Bye, Carla. Have a nice weekend.
Bye, teacher. Have a nice weekend.
Bye-bye.
Thank you, teacher.
Bye, Luisa. Have a nice
Bye.
weekend.